Hello students, and welcome to this section of Module 3.1. In this section, we really want to get into practicing using the product rule. You might be thinking in some cases, oh, I may not need the product rule, I could just use the power rule here, but I am going to challenge you to really work on using the product rule throughout this entire lesson because it's going to help you memorize what the product rule is and what situations it can be used for. So, let's get started. So as I said, we want to really use the product rule in every single one of these cases. So if I want to find f prime of x here, then it's going to be the derivative of the first. So 4x plus 3 times the second, so x squared minus 3, plus the first, 2x squared plus 3x, times the derivative of the second. So that's going to be just 2x right there. All right, and at this point, it's all about simplifying. All right, so that's going to get me 4x cubed minus 12x plus 3x squared minus 9. And then over here, I'll get plus 4x cubed plus 6x squared. All right, and so what is our final derivative when I combine all of those like terms? Well, I'll get 8x cubed plus 9x squared minus 12x minus 9. And so that's me using the product rule in this case. So let's jump over to our second example. G of x is the square root of x times x squared minus 3x plus 2. And let's find g prime of x. All right, so the derivative of the first, well, what I really want to take note of is that this is x to the 1/2 real quick. And so when I take that derivative, the 1/2 comes down. So 1/2 x, let me rewrite this actually. I won't put it down there. Hopefully you are at the point where you're taking those square roots very quickly. But I will write this 1/2 x to the negative 1/2 times the second. So x squared minus 3x plus 2 plus the first, so x to the 1/2. Times the derivative of the second, so 2x minus 3. All right, and so let's continue finding this equation. So I am going to distribute here. That's going to get me 1/2 x to the 3/2. And then I get minus 3/2 x to the 1/2. And then I get plus x to the negative 1/2. And then over here on the second part, I get, let me see, that's going to be 2x to the 3/2 minus 3x to the positive 1/2. All right, let us continue simplifying here. So 1/2 plus 2, that's going to get me 5/2 x to the 3/2. And then I've got these halves for exponents. So minus 3/2 minus 3. So that's going to get me minus 9/2 x to the positive 1/2. And then lastly, I think I've got just this x to the negative 1/2. So plus x to the negative 1/2. All right, and let's write everything out back in radical form because I started with the radical. So we write this all out back in radical form. So 5/2. So 5x, wait, I messed up right there. 5 times the cube root of x squared all over 2 minus 9 times the square root of x over 2 plus 1 over the square root of x. All right. So everything looks pretty good there. I know it's not that it's not the simplest of problems to go through, but just keep thinking like this is a repetition of the power rule. You really need to get that power rule down, especially with square roots and fractions, things like that. All right, moving on here to our third problem. I have f of x equal to x cubed times sine of x. So let's take our derivative real quick. So it's going to be the derivative of the first, so 3x squared times the second, plus the first, so x cubed times the derivative of the second. And that's a good derivative, but if I just wanted to simplify this a little bit, take out some of these like terms, I could take out x squared here, and I will have 3 sine x plus x cosine x. So again, it's a matter of taste whether or not something can get simplified. Is that more simplified than the line above that? I don't really know. It's a matter of taste. Maybe if that x squared were to divide out, then that would be helpful. Over here to our fourth example, if I want to find this derivative, h prime of x, well then that's going to be the derivative of the first, which is 3 times cosine x, plus the first, so 3x plus 2 in parentheses, times the derivative of the second, so that's going to be times negative sine x. So we need to simplify this real quick. So 3 cosine x, I guess I'll distribute that negative sine x, so that's going to be minus 3x sine x minus 2 sine x. All right, because I'm distributing that negative and the sine of x into both of those terms, 3x and 2. There doesn't seem to be anything that I can simplify here, so that looks like that's going to be our final answer. Again, using those tools that we learned in Module 2 for the derivatives of sine and cosine. So now I want to look into our fifth problem. G of x is 3 theta plus theta sine theta. Because this is an interesting problem because you got to do it in different parts. So if I want to find g prime of x, well, I'm looking at 3 theta. That's not a product rule. I'm just going to be taking that derivative. So 3 theta, the derivative of that would just be 3. And actually, as I'm working through this, I see that there is a bit of a typo. Either these thetas should be x's or the x should be theta. So that we have a consistent variable throughout, but it's just a small typo. I can fix that over here. There we go. So g prime of theta. So that's going to be equal to 3 plus, now we're going to use the power, or the product rule. I always mess up the 2 p's. So now we're going to be using the power rule. And so it's going to be the derivative of the first, so theta. So I'm looking at this part right here, and there's 2 equations getting multiplied together. So the derivative of theta, that's going to be 1 times the second, which is going to be sine of theta, plus the first, so theta, times the derivative of the second, so sine of theta. So the derivative of sine would be times cosine theta. All right, so let's just simplify this a little bit. I had 3 plus sine theta plus theta times cosine theta. And that's going to be my final answer here, with the sine and thetas all included. And moving on to our next one, if I want to find h prime of x, all I have to do is I have sine times cosine, and I'm going to have my first and my second function. So the derivative of the first is cosine x times the second, so times cosine x, plus the first times the derivative of the second, so negative sine of x. All right, so then I have cosine squared of x minus sine squared of x. And that's going to be our derivative. So make sure you actually do multiply those out if you can. So now I want to look at going through some practice of actually finding the equation of tangent lines. Okay, so here we have a problem where we have 2 things getting multiplied together, so t squared and cosine of t. And we want to find it when t is pi over 6. All right, so let's get started. So first, let's find our point of tangency. So to find our point of tangency, we're going to find g of pi over 6. All right, so that's going to be pi over 6 squared times cosine of pi over 6. All right, so pi over 6 squared, that's going to get me pi squared over 36 And cosine of pi over 6 would be times square root of 3 over 2. And if I simplify this, well, I mean, it's not really going to be simplified, but I'll get pi squared square root of 3 over 72. So my point of tangency would be x is pi over 6, and the y value would be this, what I just got, pi squared square root of 3 over 72. Wow, that looks like a beast, but using our point slope form for writing lines, that'll make it very easy. So now let's find the slope of the tangent line. Okay, well, first we need g prime of t, and so that's where the product rule is going to come in. So the derivative of the first is going to get me 2t times the second, so times cosine of t, plus the first, t squared, times the derivative of the second, so negative sine t. Okay, so I'm going to just rewrite this real quick. Cosine t minus t squared sine of t. All right, and I want to find the slope of the, so that's my derivative, so the slope of the tangent line, I'm going to find it at g prime of pi over 6. All right, so then that's going to be 2 pi over 6 cosine of pi over 6 minus pi over 6 squared times sine of pi over 6. Oh, wow, what a beast. Okay, so 2 times pi over 6, that's going to get me pi over 3. And cosine of pi over 6, that's square root of 3 over 2 minus pi squared over 36. And then sine of pi over 6 is 1/2. All right, so we need to really work with this. So I have pi square root of 3 over 6 minus pi squared over 72. Can I simplify this at all? Okay, so if I were to combine everything, if I could multiply this by 12 over 12, then I could combine it all into one fraction, which might be helpful, like just to rewrite it. So again, we're finding that slope value at pi over 6, so that's going to be 12 pi times the square root of 3 minus pi squared all over 72. So now I have all the bits of information that I need in order to write the equation of the tangent line at pi over 6. So it's going to be y minus the y value that I found, so that's going to be minus pi squared square root of 3 over 72. And it doesn't need to look pretty to be the equation of the tangent line. Equals my slope, so 12 pi square root of 3 minus pi squared over 72 minus, and I'm running out of room a little bit. Let me see if I can move this. Can I move you? Look at that magic. All right, so here we go going on. So that's going to be times x minus the x value where we're finding this. So x minus pi over 6. So this right here is going to be the equation of the tangent line. What I would encourage you to do is to graph our original function g of t, graph our equation of the tangent line, and make sure that you can see it happening on your calculator, that you do have that point of tangency at pi over 6. And I want to continue this idea going on here. Because we learned a very, very valuable lesson when we were introduced to the product rule. So on our previous page that you were doing, I want to take a quick look at this question that we had. Okay, and so the answer that we got for that was f prime of x is equal to 5 halves x to the 3 halves minus 9 halves x to the 1/2 plus 1 over x to the 1/2. And I know we rewrote it, but the reason I'm writing it as this here is because I really don't want to get into the weeds on this as I go into rewriting these in polynomial form. So what I want to think about here is what would happen if we were to distribute at the beginning and then find the derivative. If I were to distribute at the beginning, let's see, I would get x to the 5 halves minus 3x to the 3 halves plus 2x to the 1 half. And now if I were to just use the power rule here, that would be 5 halves x to the 3 halves minus 9 halves x to the 1 half plus x to the negative 1 half. And this little part right here would turn into 1 over x to the 1 half. Okay, so you can bring everything else down right there. Let me do that real quick. So 5 halves x to the 3 halves minus 9 halves x to the 1 half plus 1 over x to the 1 half. And what you want to notice is that these two things right here are the exact same. All right, so the valuable lesson that I want you to get out of this, and what I've been kind of remarking on a little bit, is that if you can do it, if you can distribute, it's probably going to be faster. And that's exactly what I wrote here, because the algebra that you're doing, if you were to go through that previous problem using the product rule, it got really messy and things really, you had to distribute multiple times. You had to distribute many more times than you had to if you were to just do it at the beginning. So keep that in mind. If you can rewrite it in polynomial form and just do a repetition of the power rule, do it. Because we're going to illustrate that here, because if I've got 3 things getting multiplied together, it would just be so much faster to find the slope of the normal line if we were to distribute everything. So let's distribute everything here. So g of x is going to get me 2x squared plus x minus 3 times x plus 3. And then if I were to distribute that again, I would get, let's see, 2x cubed plus 3x, nope, that's wrong, plus 6x squared. And then I get plus x squared plus 3x minus 3x minus 9. All right, and if I simplify everything, I would get 2x cubed plus 7x squared. Those cancel out, minus 9. And now let me just find g prime of x real quick. So that's going to get me 6x squared plus 14x. And so that's gonna, even though it's like 4 steps of work, it's gonna be so much faster than doing multiple product rules. And then like you're gonna end up distributing like 12 times in the end. This time it was very fast. So now we want to find the slope of the tangent line first. All right, so our slope of the tangent line, so we want g prime when x is 2, so g prime of 2, and that's going to get me 6 times 2 squared plus 14 times 2. So that's going to get me 24 plus 28, which is 52. But I'm not done because I want to find the slope of the normal line. So slope of the normal line is going to be the negative reciprocal, or negative 1 over 52. And that is actually, this answer right here is actually going to conclude this lesson here. We do have one more video coming up, so just stay with it. I know this one seemed a little bit meatier, but I want to show you how you can use the product rule if you're given graphs, if you're given tables, because we just went through it finding a lot of functions. But remember, we have to look at tabular form and graphical form as well. So stay with it. I'll see you in the next video. If you do need any help on this section, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez. I just cry.